right, in this section, we talk about what we do with our exponents when we divide. The previous section was about multiplication and exponents. This one is about exponents and division. Again, there's a way to write out our exponents where we're guaranteed to get these correct. So on top here, 8 to the 10th means I am going to write 8 or 10 eighths. So there's 10 times, or 8 times 8, 10 times. And then on the bottom, it's 8 to the 7th, which means 8 times 8 times 8 times 8 times 8, 7 times. I just did one too many. There we go. Now, when we divide numbers, and there's the same number is on top as on bottom, these can cancel. So I'm going to cancel out however many numbers are the same. And here, I am left with 8 to the 3rd, 3/8 on top. I shouldn't put 8 to the 3rd. I should just put 8 times 8 times 8 on top, which does equal 8 to the 3rd. The shortcut here, when we divide like bases, if you can see, we have like bases, 8 and 8. Those are like bases. We subtract our exponents, giving us 8 to the 3rd power. So either way works. Here again, I have like bases, y divided by y to the 13th divided by y to the 9th. So I take my number in the numerator, 13, and I subtract the number in the denominator, which is 9, the exponent in the denominator, I should say, which gives me y to the 4th. Part D here, I have like bases, d and d. My exponent in the numerator, I subtract my exponent in the denominator to give me d to the 7th. Here we go. Let's try that right here. When I divide like bases, which I have, g is my like base, I subtract my numerator from my denominator, the exponent in my numerator from the exponent in my denominator, leaving me with g to the 12th. And here, does a to the 12th over a to the 8th have the same value as a to the 6th over a squared? Well, let's try. So two ways to write these out. What we've just learned is when I divide like bases, which I have like bases right here, I can subtract my exponents. Let's do this. There we go. A is the base. Exponent in the numerator minus the exponent in the denominator leaves me with a to the 4th. There's also the long way of writing it out that is guaranteed to help us get it right. And we can cancel these, right? And I have 4 a's on top, which a times a times a times a is a to the 4th. Or we can do what we have learned above, where when we divide like bases, we subtract our exponents, the exponent in the numerator minus the exponent in the denominator, and I get a to the 4th both times. Again, let's write this down. When we divide like bases, we subtract our exponents. Now, power to a power. Just like last section, when we have a power to power, everything inside the parentheses has an exponent, even if an exponent is not written. So this 5 in the denominator did not have an exponent written. If there is not one there, we put a 1 in its place. 3 is on the outside, and again, we are going to distribute that exponent on the outside to all of the exponents on the inside. Again, you can only multiply exponents by other exponents. So 3 times 7 is 21, so I have a to the 21st over 5 to the 3rd. A little bit more simplifying, 5 to the 3rd power, 5 times 5 times 5 is 125. So simplifying this, again, there are terms in here that do not have exponents. I need to give them an exponent if they don't have it. If an exponent is not initially written with a number or a variable, that means it has an exponent of 1. So there I have rewritten the expression with exponents given to everything, because every term has an exponent. Power to a power, we distribute, meaning we multiply exponents by other exponents only. We only multiply exponents by other exponents. So I'm left with 2 squared x to the 6th over 3 squared times y squared. 2 squared is 4. There's more simplifying left because 2 squared equals 4. 3 squared is 9. Y squared. Nothing else I can simplify because 4 over 9 is as simplified as it goes. All right. Again, we're going to rewrite this, but give all terms exponents. So that's 4 to the 1st in the denominator. There it is rewritten. And I am going to show that I am distributing only to my exponents. Exponents times other exponents only. So I have a to the 8th over 4 to the 4th times b to the 3rd. And again, there is some more simplifying here that we can do. So a to the 8th stays a to the 8th. 4 to the 4th equals 256. 4 times 4 times 4 times 4. And b to the 3rd. There is no more simplifying left. And down here, there's nothing we need to write here. We can just simply use this as a reference if we would like. Again, when we divide like bases, we subtract the exponent in the numerator by the exponent in the denominator. Here's how that is written algebraically. And when we have a power to a power, remember, if exponents are not there, we should put them with 1, and we distribute exponents to other exponents only. And then we should simplify this to be 9 over 25.